about the power of community in the morning, this is how it works. So thanks Ian for providing the laptop and everybody else for putting the system together. So, as I mentioned in the morning, I will talk about StarlingX during this presentation. In the next, 30 or something minutes, I will try not to run way too much over than how much we already are. So, what is StarlingX? Has anyone in the room heard about it? Maybe tried it already, know what it is? Very few. All right. Then you may get bored a little, but I will talk more about what the project is, how it looks like, and how you can join the community if you're interested during this presentation. So we mentioned in the morning we have a couple of new OpenStack Foundation projects. StarlingX is one of the new ones. It is still a pilot project. We brought it under the OpenStack Foundation umbrella around summer last year. This is a project that is focusing on edge computing as a focus area and trying to provide a platform that is optimized for edge computing and IoT use cases. There is already a release out. It was released in October last year. The good news is that there will be a new release coming out in a week. So you have a chance to try out a way new version of StarlingX with new features and functionality really soon. It is also a fully open source project, Apache 2 license, open source community around it that we are still building, so you're very welcome to join and participate. So a little bit of background that I will not spend a lot of time on. I assume all of you heard about edge computing in some extent. We have a lot of new use case ideas and new demands, augmented and virtual reality, connected cars, drones flying around and doing all sorts of things around us, enhanced healthcare, smart cities, and the list is really endless. What a lot of use cases within these areas require is to have computational power closer to the end user than what we had before, because it's not efficient if you have to send all the data back to a centralized cloud or centralized data center, whatever is running there, because you have a lot of latency and you can't always afford that. Also, you don't always have stable network connectivity between the centralized data center and your end user device and all these kind of things. So basically, we are kind of restructuring how infrastructure is built, and with all that, we are creating a lot of new challenges for ourselves. So distributed systems are not easy. Any of you who's building and or operating massively distributed systems know how hard the challenge is. And with edge computing, we are basically taking this challenge to the next level. So we are having a massively distributed system of massively distributed systems with sometimes hundreds or thousands of edge sites and edge locations that you have to be able to somehow manage and still connect back to a centralized system most of the cases, because you need to store data long term, or you want to analyze data further than what you've done closer to the end device, and all these kind of things. So StarlingX is fully integrated open source platform that is trying to address this challenge of how you're deploying and managing a system like this. So how the project is structured, basically it's not just OpenStack services or other OpenStack Foundation projects. Basically what the community is doing, they're integrating together well-known open source components like OpenStack Kubernetes, Staff, KVM, Libvirt, really long list again, and also adding some new services themselves to address a variety of use cases. The project is not focusing on any industry segment in particular. Of course, if you look around today, the most activities around edge computing you can see in the telecommunications industry segment. The operators are building and reshaping their networks and backbone networks, how they work and what they provide for you. 5G is knocking on the door these days, so we will soon have a better infrastructure for a lot of edge computing use cases. But until we get there, that's basically the industry segment where everything is starting right now. And you will see more and more use cases around, I don't know, healthcare, manufacturing, to mention some examples. I also mentioned smart cities, industrial IoT, and all these kind of things. So the project is really trying to provide a modular, flexible, customizable platform for you. So depending on your use case, you can shape it in a way that should be suitable for you. In a bit more detail, which unfortunately not very readable on the slide, but I think you will have access to the slides after my presentation, and it's also available online on the StarlingX website, so you can go there and take a look. Basically, this diagram is kind of a very high-level architectural diagram in the sense of showing you what projects StarlingX is integrating, like which components it is using, for example, from OpenStack and Kubernetes, which are big chunks of the platform. And you can also see that there are some services which are developed within the StarlingX community. So those components like configuration management, fault management, and so forth, those are the components which are kind of missing pieces today when you look into the open source ecosystem. So what we mentioned this morning, that it's one thing that you deploy a distributed, a massively distributed system, but how you operate and manage it starting from the next day. So the community is focusing a lot on making it as easy for you as possible, both making it easy to deploy it and then making it easy to manage and maintain. Because when it comes to edge computing use cases, sometimes that edge site is on the top of a mountain, for example, or at a location where it is really hard to send a human being to fix something if it went wrong. So again, automation is really, really important, and challenges like zero-touch provisioning that are more and more popular these days are all in the focus of the community as well. And there are some more examples of other open source components integrated. So when it comes to Edge, you cannot really attach a number to how the infrastructure looks like, how many Edge sites you have. It is highly dependent on the use case. So the StarlingX community is focusing also a lot on making the project scalable, so you can run it on one single server. Obviously, you're losing some functionality, for example, around high availability, because you just can't really do that with one physical machine. But if you have more resources available, you can also set it up in a dual server or multiple server environment, which then gives you some redundancy, and you can achieve things like high availability, or also make the system geographically distributable as well. So when you look at scaling from a different perspective, I talked about different architecture models for edge computing, because there really is no one-size-fits-all solution for edge because of the variety of use cases. And the StarlingX community is working together with the OSF Edge Computing Group when it comes to defining and testing edge computing architectures. And what we've identified so far is working on an architecture model where you have a centralized control plane scenario with the control plane function running at one place, and you have a different size of edge sites attached to that. Or the other way around, you have the control plane services in a distributed manner, and you just have some high-level management and orchestration functions in a centralized place. Both of these have their advantages and disadvantages. For example, when it comes to losing the network connectivity, if you have a centralized control, then your edge sites end up with limited functionality in case their connection is lost to the centralized data center. And the other way around, it can be complicated to manage many fully autonomous edge sites. So if you have the control plane functions distributed all over. StarlingX is implementing the distributed control plane scenario. They have geographically distributed multi-region deployment, as you can see on the diagram here. You can also see that they are supporting different size of edge sites attached to or connected to a central data center where you can have some orchestration and synchronization services available, just to make sure that this whole thing is really operates as one system as opposed to separate entities. So I mentioned that StarlingX has a couple of services that the project is developing and implementing themselves. So these services are not picked from any other community or project. So one of these is configuration management. So again, trying to make your life easier. So when you have a new node, this component is supposed to make it possible to auto-discover these new nodes and also to kind of keep an inventory of configurations, available resources for you. So when you discover the new node, then you can set up the configuration. You will know how much resources you have available in that particular node. On the diagram, you can see that you have access to this component both through CLI or Horizon. This is also part of the project that the interfaces are accessible through REST APIs and the community is integrating all the functionality into Horizon that I assume you know very well from OpenStack. Another new component is host management, so providing lifecycle management for your bare metal machines to the level of detecting failures and also providing some recovery actions in case something went wrong. It provides monitoring and alarming functionalities, and it's also connected to the hardware's BMC, board management controller, so you can provide, the system is able to provide steps like powering on or off machines or resetting the hardware in case needed. Service management is making sure that if you have, if your environment supports that, then it can provide you different redundancy models to make sure that you have a highly available system and you're not running into challenges when it comes to keeping SLAs with the service level agreements. The system is also set up in a way to trying to avoid split brain scenarios. So when you have some network connectivity loss within the environment, the remaining bits and pieces know what to do, as opposed to everyone trying to do the same thing in parallel in a disconnected state. Similarly, as for hardware, you also have monitoring of services. So when it comes to StarlingX, you basically get monitoring of the full infrastructure, both hardware and the services that are running on top of it, to make sure that, again, if you have any problems within the system, then the management components can interact, react, and correct those as much as possible. Software management is providing you the possibility to run updates and upgrades when it comes to like patching a component or fully upgrading your system in a rolling upgrade kind of fashion. So that is also supported within the project, and fault management component is when I talked about having monitoring both for hardware as well as the virtualized resources. You also have a component that gives you the possibility to define custom alarms, and it also provides you a centralized logging functionality, so you can look up what happened within the system and do optimizations and corrections if needed, or just analyze a particular failure scenario if it happened. Similarly, as I mentioned earlier, you have access to the component through a REST API, and it is also integrated into Horizon for an active alarm list, for example, and to manage logs. The project is working on a distributed cloud feature. As I mentioned, within the centralized component, there are orchestration and synchronization functionality, which is basically coming from the distributed cloud component. The StarlingX community is looking into solutions as, for example, database replication. When it comes to synchronizing data between edge sites, the feature is based on OpenStack regions in the first release, and the community is working on to evolve this component as well as some of the others that I will mention a little bit later. So basically, what you can do when it comes to building an edge environment, an edge solution, is you can either go and do it all yourself, which is very, very time consuming, and you have all the gaps to fill that I mentioned before. The community has been working on for a bit more than a year now. Or you can go and try out StarlingX, which provides a lot of components that will make your system easier to manage, deploy, as well as manage, and gives you a complete, fully tested edge stack. The community, again, is working a lot on also testing the software in various ways. So it's not just unit testing and functional testing, but they're also running a lot of robustness testing on its sanity tests, making sure that the system is continuously deployable, and it is also robust and resilient to failures. Anyway, all right. I think I have a few slides missing from here, but I will talk about the missing items at the end. So, community and contributing. As we talked about in the morning keynote, it is really important when it comes to open source that all of you who are interested in a particular technology and solution come and participate in the community to basically let us know what works for you, what requirements you have that the community can work on to address, or if you found any bugs to fix, come and report them and help us fixing it. The project follows the 4 opens that I will not repeat here, but again, it is a really important set of guiding principles that all of the OpenStack Foundation projects have to follow in order to be able to become a confirmed project under the Foundation umbrella. Similarly to other projects, this project also has a governing body that we call Technical Steering Committee, making technical decisions, and the community is committed to diversity and openness, and I hereby would like to encourage all of you to come and participate. When you look deeper into the project, it is very similar to OpenStack and many other projects, so it has a lot of well, not a lot, but a couple of components with teams organized around them. Some teams are organized around like supporting functions like testing or documentation. Some projects are focusing on technical parts like containers, for example, and we also have a couple of projects around main functionality, like the services that I listed, configuration, software, fault management, or, for example, distributed cloud. Each of these project teams have a technical lead and a project lead, and core reviewers and contributors, which terms I believe are familiar, most of you who know how OpenStack works. So a little more detail about what these roles are. We consider everyone a contributor who has made a contribution in the past 12 months. And this can be code or testing or documentation. You can serve in a leadership role. So we really do not tie the definition of contributing to code itself. We consider contribution something that is a way broader term, so you don't have to be a software developer or software engineer in order to be able to participate in the community. Core reviewer is again a very similar term that what we have in OpenStack. Each project has this core maintainer team who are basically maintaining the vision and kind of strategy for a particular sub-project, and also making sure that the code quality and documentation quality remains high. I mentioned technical and project leads. This basically, if you're familiar with how the OpenStack community is structured, there we have the project team leads, like PTLs, kind of serving both of these roles at the same time. The StarlingX community decided to split some of these responsibilities into 2 roles. So we have a technical lead and a project lead. The technical lead is responsible more for the technical direction that the sub-project is taking, while the project lead is kind of making sure that the project is organized, is able to deliver within the agreed release cycle, and kind of also acts as a sub-project ambassador and making sure that all communications happen both between project teams and also outside externally to the project as well. We have a technical steering committee. This slide needs to be updated slightly, but basically this is the governing body that's kind of responsible for the technical direction of the project and making sure that the decisions are harmonized and also synchronized within sub-projects. The technical steering committee is election-based, so the community will be having the second TSC elections running this October, so it's not too late if you would like to get involved and looking for opportunities to take on a leadership role. You need to be a contributor in order to be able to participate in the election. And yeah, more details are on the website. I will not go into that. I mentioned already that this is an open source project under the Apache 2 license. You can find the code up on the web, git.starlingx.io. You can also reach the community on a free node, so IRC, and mailing list as well. I suggest you to, if you're interested in just kind of learning what's happening in the community or participating, being able to communicate to people, to sign up to the mailing list. That's where most of the communications happen besides the weekly calls and meetings. So it is the easiest to follow the project, to kind of read the emails that come to the mailing list and participate in some of the discussions that happen there. It is not a super high traffic mailing list. You will get a few mails per day, but it's not like what we have discussed where you get hundreds, where the amount of emails that you get is more around hundreds per day, so it will not immediately fill up your inbox. There are a couple of links in the slides around where you can find the bug tracking or the new features and functionality that are on their way. The StarlingX community also decided to have a specifications, specs repository, so you can look that up for kind of list of new features that are under development. For more details on those, we have a storyboard project defined, and bugs are on Launchpad. Community, again, come join and participate. You don't have to be an individual OpenStack Foundation member in order to be able to contribute code or documentation or write a blog post about the project or anything like that. However, if you would like to participate in elections, we require foundation membership for that. And also, if you're contributing on behalf of an employer, then look into the corporate contributor license agreement before participating. I mentioned these resources before. I would just highlight the meetings wiki page where you can find the weekly calls. I would suggest to dial into the community call, which is, I believe, on Wednesdays, which can be, again, a good starting point to understand where the community is currently and where you can join and participate. And mainly that was it. So I'm hoping I managed to get some time back. So I wonder if there are any questions.
So this question is based on some of my assumptions. It can be right and be wrong. So first of all, OpenStack operates based on the assumption that layer 2, the Ethernet infrastructure is already there. Secondly, I see here Starlink you always DPDK. DPDK only capable of mapping the host, the real host, into the Ethernet networking point. But when we talk about edge computing, there is other layer 2 transportation network. So is there any plan or any existing sub-project that can cover other layer 2 transportation?
That can cover, sorry, I didn't catch that.
I mean, that can cover other type of layer 2 transportation. Because right now we are only, on the previous slide, you say we need an existing layer 3. But if we do not have Ethernet on the existing layer, is there any way or any sub-project that can cover?
So we have the StarlingX project has a networking team, so they are looking into challenges on that front. And the StarlingX community is also working closely with OpenStack. So for example, the Neutron team, and they have a couple of enhancements for the Neutron project. I don't know where they are exactly at this point. I would need to look it up, but I'm happy to help you finding out more details about where they are at this point. Although what I forgot to mention, because some slides got lost on the way. Anyway, so for the second release of StarlingX, they are switching over to a container-based platform. So they are you're able to deploy OpenStack services in containers and also run containerized workloads as first-class citizens within the system. So there are a lot of changes to the main architecture that the community has been focusing on in the past couple of months. And now that they have the big architectural change coming out next week as part of the second release, they can kind of refocus on more details on both networking or GPU support or other kind of more specific functionality that's more specific to Edge itself.
Okay, thank you. Thank you. First of all, thank you for this interesting presentation. I have questions. First question is, could you tell us more about the ideal use case for this project? For example, is applied for some mobile operator network customer, or will apply for some service provider like camera computing?
What was the last?
I mean, please tell us more about the target use case for the project. And the second question is related to configuration management part. In your slide, you show that you are using the Puppet, right? Is there any reason you choose Puppet, or you can use Ansible also?
Okay. So for the first question around use cases, I think the project is currently, looking into the telecommunication industry, but I'm not sure they have like one particular use case that they chose to optimize the project for. So basically you can look up examples. For example, the StarlingX community is working with the Arduino community, and there you can find demos, for example, running StarlingX with EdgeX, which is a great example of integration and collaboration between multiple communities, and also giving you one use case example of what to run on top of StarlingX. The intent of the project is really is not to get specialized for any particular use case, because that narrows the scope down a lot, but rather providing a platform that you can run any type of workloads on. So virtual machine, containers, bare metal, whatever fits your use case. I believe the project is currently not being able to scale to thousands of edge sites. So that might be a limitation when it comes to use cases where you have to scale out like a lot, which the community needs to work on to improve into that direction. Configuration management, I don't know the details of that one. I mean the choice behind Puppet, and there also might have been some changes now with the new container-based architecture. I know that they worked a lot on making sure that all these new components are fitting into the new architecture, and they are working, for example, with the Azure community, bringing in Helm charts and Armada. So I believe that probably they've also been looking into things like Ansible, but I don't know the exact state. I would need to look it up.
Ok. Vì thời gian của mình đã có hạn thì bây giờ thì ai cũng gửi câu hỏi thì sẽ cho được riêng với speaker được không? Thì chuyển sang câu bi tiếp theo.